So here we have equations of lines. Now we are to solve for this time your line in R cube. You're already familiar with equations of line in R squared, diba? So in R squared, we have this. Y is equal to mx plus b. We know that this one is an equation of a line in R squared. It does not describe a line in your 3D. So, but in your 3D, this equation describes actually a plane. Okay? So, this time, we would like to know the equation of a line in R cube. So, we can actually write down an equation of a line in a 3D space. How do we do it? So, first, we have to look at your vector functions. An example of a vector function is this. R of t is equal to, this is the vector notation, t comma 1. Then you have this, no? A vector function is a function, it says, that takes one more variable, 1 in this case, and returns to a vector. So, ito takes one more variable. In this case, ang variable na yun is this one here. Note that a vector function can be a function of two or more variables. So in this case, two variables lang yan, but we can have a function also in three variables. So in this one, you have, it returns a vector in R squared kasi two variables lang. In equations of lines, we are going to make use of the function that returns a vector in 3D or in R cube. How do we do that? So we have what we call your graph of the vector function. So if you remember, we discussed before your position vector. The position vector V is equal to AB is actually a vector that starts at the origin and ends at the point AB. Okay? So if you have the point zero, origin is at point 0, 0, diba? So if it is a 2D, so it starts at 0, 0, and you come up with the point AB. So to get the graph of a vector function, all we need to do is to plug in some values of the variable and then plot the point that corresponds to its position vector. And then connect the dots. So these are some evaluations for our example. Ganyan itong V, A, B. So you can have the vector R, the negative 3 will now be negative 3, 1. A vector R at negative 1 is negative 1, 1. The vector R at 2, you have 2, 1. And you have vector R 5 is 5, 1. Notice, what did you notice? Puro nasa 1, no? It takes it at value 1. So, ano itsura nun? This is the sketch. At negative 3, 1, ito yung line which is equal to 1. So, each of these are position vectors representing on the graph of our vector function. So, ang points na negative 3, 1, so yeah, negative 3, then you have the value at 1. 1 man itong ditong y ninyo. Okay? Negative 1 at negative 1 ang x, 1 pa rin. Ito pa rin. And at 2, you still have also 1. At 2, 1 pa rin. Ito. At 3, 1 pa rin. Now, this is the graph of the line. So, the points, these points are all points that lie on the graph of our vector function. That is, if we do some evaluations and plot all the points. Ito ang itsura niya. Okay? So, in the sketch, we have included the position vector, which is your gray dashed line. Ito mga gray dashed line. Those are the position vector. And for several evaluation as well as above each point, we use for each evaluation, how does it look like? It looks like actually the line equal to 1. So the graph of the vector equation is in fact the line y is equal to 1. So pwede pa rin mag-draw ng line, kahit nasa 3D tayo. Another example would be this. Okay, but graphs of vector functions do not have to be lines, as the example above shows. No? In this case, we get an ellipse. Later on, mag-sketch man din tayo ng mga quadratic surfaces ninyo. Now, what have we done so far? Recall that we want to write down the equation of a line R cubed in R cube, as suggested by the work above. So we actually need a vector function to do this. But what do we consider now? Suppose that we know that the point is on the line P sub 0. The point is on the line where your P sub 0 is equal to X sub 0, Y sub 0, Z sub 0. So this point is on the line. Suppose na ay naatay point sa line. Kani siya ang iyang coordinates. Tapos natay vector V, which has A, B, C, which is parallel to that line. So we need a point and we need a vector V, which is parallel to the line. It's not necessarily true that V is on the line itself. No? So pwede na ang V, ang vector, wala siya sa line itself, pero dapat parallel ang vector V. So we only need V to be parallel to that line. And then we can let P be equal to a point with coordinates X, Y, Z. This can be any point on the line. Now we need our slope. We know that our slope is a vector. And we can represent the 2 points of the line as actually vectors. Diba? If you remember, nag-discuss na pag naatay vector V, you can have P sub 0. Diba? Ito, V. In this case, ang ginamit niya, dinefine niya ang A to be P sub 0 to P. Pwede rin niyang V ang vector na yan. No? Pwede man nating i-name. Kaya nga sabi niya, for no apparent reason, let's define vector A to be P sub 0 to P. Because I can also define this as vector V. Okay? I can call this as V. Or if you want, I can call it as vector A. Okay? So your R sub 0 and R be the position vectors for P sub 0. Okay? Or P sub 0 here, a point on the line, P sub 0, and P respectively. So another point on the line is your P. Anong itsura niyan? This is the sketch. You have the line. And you have your X coordinate system, your Y, and you have your Z. We have shown that the vector V as a position vector, but it doesn't need to be pwede po na dili sa position vector, no? Pero dapat lang, parallel ang vector V, no? So you have your vector V, which is parallel to your P sub 0 P. It can be anywhere. So a position vector on the line or off the line, it just needs to be parallel to the line. So ito yung line ninyo. Ito yung position vector ninyo na V. Okay, parallel siya dapat yan. Ano yan? Vector form of the equation of the line now can be computed as follows. Notice that we can write R as follows. R is equal to R sub 0 plus the vector A. Why? You remember yung nag-add up ng mga vectors sa intro natin? So if you notice, if you have your R here, this is your R. R is R sub 0 plus the vector A. Diba? So kung hindi nyo pa yan na-gets, please go back to our vector arithmetic. Kasi diniscuss yan na yung vector R is your R sub 0 plus the vector A. When you add two vectors, ang resultant vector is this one. So R vector is equal to R sub 0 plus the vector A. Notice that the vectors A and V are parallel. So ano yung itsura? Tingnan natin. Vectors A, ito yung vector A natin, and vector V are actually parallel. Therefore, there is a number T such that you have A is equal to T times the vector V. We now have the form of the equation of the line. So this one is actually a fact that you can actually, if two vectors are parallel, then you can express that vector to be a, a vector with a constant that you can multiply. No? So pag parallel siya, the vector A is equal to some t, a number t or a constant t times a vector v. Pwede siya ma-express as such. So we now have a vector form of the equation of a line, which is r equals r sub 0 plus tv, which is equal to x sub 0, y sub 0, z sub 0 plus t times you have a, b, c, where your the value for x sub 0, y sub 0, c sub 0 here are actually what? Itong mga points diri. Kaning points ninyo sa yun? X sub 0, y sub 0, z sub 0. And your v is your a, b, c. The vector v is your this one, a, b, c. So we now have derived the vector form of the equation of a line. So the only part of this equation that is not known is the t. But notice that t times the vector v will be a vector that lies along the line, and it tells us how far from the original point that we should move. Pag positive ang t, then we move away from the original point in the direction of v. So right in our sketch. If t is negative, then we move away from the original point. Pag negative, which is the opposite direction of v. Left in our sketch. No? Dito sa sketch natin. So right, papunta doon. Pag positive, pag negative, papunta dyan. Okay? So we're following our sketch ito. T greater than 0, t less than 0. This is the line there. So pareho lang. And you will be able to get the equation of a line. So in other words, we now actually have what we call your parametric equation of a line. So there are several forms of the equation of a line. To get the first alternate form, you can have the following. You make use of your r vector, which is equal to x sub 0, y sub 0, z sub 0 plus some constant t or number t multiplied by abc. Or you can write it as your r now is, the vector r has components x, y, z, which is equal to, diba, pag mag-add kayo ng dalawang vectors, it's simply x sub 0 plus component by component. So x sub 0, this, you can multiply that ta. So yeah, plus ta, comma, y sub 0 plus, this is tb, so tb, z sub 0 plus, this is tc. So the only way for two vectors to be equal is for the components to be equal. So meaning to say, kasi equal man daw sila, ang equation natin, parametric equation of a line will now be x equals, ani siya, equal to this. Kaya we only can have two vectors to be equal if ang iyang component is equal to the component. Kada isa ka component equal. So that means to say x now is equal to x sub 0 plus ta, y is equal to y sub 0 plus tb, and z is equal to z sub 0 plus tc. Ang tawag dito is your parametric form of the equation of a line. Hello, are you still with me?
Yes, ma'am.
Yes, ma'am.
So this is the first equation. We actually had derived the parametric form of the equation of a line. Sometimes hindi ko na diniderive, but since we have enough time, kasi I presume you already have watched all the video clips 1 to 5 ba yun? 1 to 5 yung siya. Lectures 1 to 5. No? So lecture 6 ito. But anyway, ang importante dito is that you know how to get the parametric form of the equation of a line. And then from this parametric form of the equation of a line, we actually have what we call your symmetric equations of the line. So the symmetric equations of the line, take a look at this. This x equal to x sub 0 plus ta. Bale, ang gawin is ilipat ito x minus x sub 0. Yan. Then, you divide both sides by A. So you will have x minus x of 0 over A equals t. So you have this. X minus x of 0 over A equals t. Pero pareho man sila lahat na t. T rin ito. Y minus y sub 0 over B equals t. Then z minus z sub 0 over C equals t. So equate sa lahat. You now have your x minus x sub 0 over A equals y minus y sub 0 over B equals z minus z sub 0 over C. That is, as long as we assume that A, B, and C are all non-zero numbers. Kasi if may isang zero dito, hindi pwede. Kasi we cannot divide this by a zero. So as long as we assume that A, B, and C are all non-zero, we can solve each of the equation in the parametric form of the line for T. And we call this your symmetric equations of the line. Now what happens pag naiisa na zero? So we go to the following. If one of A, B, or C does happen to be zero, we can still write down the symmetric equations. So let us suppose that B equal to 0. What will happen? So T will not exist in the parametric equation for Y. So ang mangyari, if Y is equal to ganito, we will now have, instead of Y minus Y sub 0 over B, maging na siyang x minus x sub 0 over A equals z minus z sub 0 over C, then you will have y is equal to y sub 0. If in case naman na ang C ang 0, what will happen? Pag C ang 0. Hello?
Lang z ay z equals
Anyone?
z sub 0.
Yes, pakilakas.
Z equals z sub 0.
Z is equal to z sub 0, and then, correct? And then ito, ano mangyayari?
X equals x sub 0.
X minus x sub 0 over A equals y minus y sub 0 over B. And then you will have z is equal to z sub 0. Correct. Ha? So, kailangan pa rin itong dalawa dito. Para if in case na C is equal to, yung C dito, letter C is equal to 0. Pag A naman ang equal to 0, kanina po ang mahimong x is equal to x sub 0. Na, kanina po siyang mabutang dila. Okay? Sige. Now, there are some problems here. Example, write down the equation of the line that passes through the points 2, negative 1, 3, and 1, 4, negative. Pero pag may time mamaya, I'll try to solve this one. Para makapunta lang ako sa next na topic. Okay? I have a solution. Then, let's see later on. Okay? Let me just... pwede gamitin ko yung isa. Nasa isa kasing PowerPoint. Sige, solve na lang natin. Tingnan ko na lang. Let me just stop the recording muna dito. Stop sharing. Sige, solve na lang natin para diretso